Welcome everyone. I welcome again. Today I will teach you third lesson, elements, compounds and mixture. Everybody take page number 24. Everybody take page number 24. The third lesson, elements, compounds and mixtures. What is that? Elements, compounds and mixture. Now first of all we will see about properties of substances. We will see about properties of substances. We will study the property first. We will study the properties of substances. I will show the slide. Now, children, look at this. Look at the PPT. Properties of substances. What is that? First of all, we study about the properties of substances. All substances have characteristics properties that distinguish them one another. All the substances have the characteristics properties. பொருட்களின் பண்புகள். Properties of substance. What is in Tamil meaning? பொருட்களினுடைய பண்புகள். So all substances have characteristics property that distinguish from one another. How can we distinguish them? How can we distinguish them? If they have characteristic property that helps to distinguish them from other substances. Now, first of all, we go to see the physical properties of substances. What is then? First of all, we go to see the physical properties of the substances. Look at this, children. Properties of substances. All substances have characteristic properties which distinguish them from other. So now physical properties of substances are, therefore physical properties of substances will come. What are the physical properties of substances? How we are distinguish them? How we are distinguishing them? First of all, color of solids. Color of solids. In the color of solids, non-metals, metals, salts, they are in separate column. What are the differences between the non-metals, metals? What are the differences? How do we identify them? Metals can be beaten. Now, I want everybody to hear this. Metals and non-metals. Metals and non-metals. What are the differences? What are the differences between metals and non-metals? First of all, metals. That metals are luster. Then ductility. Metals have ductility. Then good conductor of heat also. Metals are good conductor of heat. Not only good conductor of heat, and also they are good conductor of electricity also. They are conducting heat and they are conducting electricity. That's why this is a good conductor of heat and good conductor of electricity. These are the properties of metals. These are the properties of metals. Now, can we study about non-metals? We study about non-metals. Here, the non-metals, they brittle in nature. Then carbon, hydrogen, then sulfur, brome, they are in the non-metals. They are non-metals. What all? Carbon, hydrogen, sulfur, brome. These are all non-metals. Then next one, this is a poor conductor of heat, and also this is a poor conductor of electricity, and is a poor conductor of electricity. But metals are luster, ductility, good conductor of heat, good conductor of electricity. But non-metals, we cannot be beaten them. But metals, it can be beaten. Metals can be beaten, but non-metals cannot be beaten. It cannot be beaten. Then carbon, hydrogen, sulfur, brome, these are These are non-metal. These are non-metals. Then poor conductor of heat. Poor conductor of heat. Poor conductor of electricity also. Then next, listen children. So here non-metals, metals, salt, non-metals. Listen. First non-metals, coal is there. What is the color? Dull black. What is that? Dull black. Next sulfur. Why? Listen first. Why coal is in non-metal? Because coal is containing carbon. Coal is containing carbon. So the carbon is not a metal. The carbon is not a metal. That's why coal is a non-metal. Coal is a non-metal. What is that color? Dull black. What is the color? You have seen the coal also. Yes, children. Yes, now we are using pencil. We are using pencil. So we are using pencil also. So that color is dull black. That pencil lead, that color is dull black. Like that, the coal color also. Now here sulfur. What is that? Sulfur. That color yellow. Now metals. We come to the metals. In metals, the zinc, iron, sodium. What all? Zinc, iron, sodium. What is the color? Grays. Zinc, grays. Iron, dull gray. Sodium, silvery. Sodium, silvery. Next salt, silver chloride. What is silver chloride? That is white color. That is white color. Then copper to carbonate. That color is green. That color is green. Next, these are color of solids. These are color of solids. Listen children, first of all you must know this point. All metals, all the metals that is solids, that are solids. Non-metals are solids or gases. Non-metals are solids or gases. Now next we will study about color of gases. First we studied color of solids. Non-metals, metals and salts we have seen. Then now we will study about color of gases. What is that? Color of gases. Now children, look at this slide. Color of gases. First, bromine. What are colored? Now first of all we differentiate them. We must differentiate them. We should differentiate them. Colored gases, colorless gases. Now first we study about colored. Bromine. What is that? Bromine. Spelling B-R-O-M-I-N-E. Bromine. The brown fumes. The color brown fumes. The color is brown fumes. Next, chlorine. What is that? Chlorine. That is greenish yellow. Greenish yellow. Then iodine. Then iodine. That color is violet fumes. Color is violet fumes. Now we will see about colorless gases. What are colorless? What are colorless gases? Oxygen, carbon dioxide, carbon monoxide, hydrogen, nitrogen, ammonia, hydrogen chloride. These are an examples of colorless of gases. These are an example of colorless of gases. Next we will study about odor of gases. Next we will study about odor of gases. Odor. What is the odor? That is manam, vasanai. Yes? Now children, we will study about odor of gases. Odor, O-D-O-U-R, odor, O-D-O-U-R, odor of gases. Here we differentiate them into two. Having odor, gases having odor, gases not gases, that odorless gases. What is that? Odorless gases. First of all we have to see gases having odor. What all? What are having odor? What are having odor of gases? Ammonia, hydrogen sulfide. That hydrogen sulfide, that is rotten egg smelling. That அழுகிய முட்டை வாசனை உடையது. அழுகிய முட்டை வாசனை உடையது. So that is rotten egg smelling. That is rotten egg smelling. Then hydrogen chloride. Hydrogen chloride. Next, that hydrogen chloride is a pungent odor. What is that? Pungent odor. What is the meaning of pungent odor? That is kadumai. In Tamil word, kadumayana or vasane. Kadumayana vasane. That's why we will say it's pungent odor. Which is pungent odor? Hydrogen chloride. Which is a pungent odor? Hydrogen chloride. Which makes rotten egg smelling? Which makes rotten egg smelling? Hydrogen sulfide. Which one? Hydrogen sulfide. That the hydrogen sulfide gives us rotten egg smelling. Hydrogen sulfide gives us rotten egg smelling. Now they are having odor. They are having odor. These are having odor. Now we will see about what all odorless. What all odorless? எவையெல்லாம் வாசனை அற்றது? Oxygen, hydrogen, carbon dioxide. What is carbon dioxide? Nitrogen. These are odorless of gases. These are odorless of gases. Now we will study about taste of gases. We will study about taste of gases. Now children, we will study about taste of gases. Here that having taste. First having taste. Next, tasteless of gases. What are having taste? What are having taste? Gases having taste. That means gases having taste. Then tasteless gases. Then tasteless gases. What all tasteless gases? First of all, we have to study about gases having taste. What are first one? Carbon dioxide, hydrogen chloride, sulfur dioxide, chlorine. They all have slight sour taste. These all have slight sour taste. மிகவும் குறைவான ஒரு புளிப்பு தன்மையை உடையது. All have slight sour taste. Tasteless gases. Now we see about tasteless gases. Nitrogen, inert gas. Inert gas, that is inactivity. Manda vayukal. What is that? Manda vayukal. So that inert gases also. Inert gases, what are inert gases? Neon, argon, krypton. These are inert gas. Now that inert gas are tasteless. After that, nitrogen, oxygen, hydrogen, carbon monoxide, they are tasteless. They are tasteless. After that, we will study about density of gases. What is density of gases? What do you see in the screen? Now listen children, listen carefully. Density of gases. வாயுக்களினுடைய அடர்த்தி. வாயுக்களினுடைய அடர்த்தி. Now with respect to air, the density of gases with respect to the air. First, this density of gases, first we see heavier than air. What are the gases heavier than air? Then almost heavy. What all almost heavy? Next, lighter than air. Lighter than air. Now, first heavier than air. Heavier than, density of gases heavier than air. Carbon dioxide, chlorine, bromine, sulfur dioxide. These gases density is heavier than air. These gases density is heavier than air. Almost heavy. What are the density? What are the gases? What are the gases is almost heavy? Oxygen, hydrogen chloride, carbon monoxide. they are almost heavy. They are almost heavy. Their density is almost heavy. Their density is almost heavy. Next, lighter than air. Lighter than air. Now, ammonia, helium, neon, nitrogen, methane, hydrogen. Hydrogen is a lightest gas. Hydrogen is a lightest gas. Now, solubility of gases. Next we will study about solubility of gases. Solubility of gases, that is வாயுக்களின் கரைதிறன். வாயுக்களின் கரைதிறன். So we will study next. We will study now. Listen here, children. That is solubility of gases. Highly soluble gases also here. Slightly soluble gases, then fairly soluble. What are highly soluble? What are slightly soluble? What are fairly soluble? We differentiated them. First we differentiated them. Now highly soluble. Hydrogen chloride, ammonia. Ammonia, hydrogen chloride are highly soluble of gases. Highly soluble of gases. Next is slightly soluble. Carbon monoxide, hydrogen, nitrogen, oxygen. These are slightly soluble. அதனுடைய கரைதிறன் மிகவும் குறைவு. Next, fairly soluble. Chlorine, carbon dioxide. Chlorine, carbon dioxide. Their solubility, இதனுடைய கரைதிறன் எப்படி இருக்கும் என்று சொன்னால், that is fairly soluble. Fairly soluble. Then next we will study about nature of gases. Nature of gases. Now, nature of gases. Neutral, basic, acidic. Neutral, basic, acidic. Now, neutral gases, oxygen, nitrogen, carbon monoxide, hydrogen. Basic, ammonia. Basic, ammonia. Acidic, carbon dioxide, sulfur dioxide, chlorine. Carbon dioxide, again I say carbon dioxide, sulfur dioxide, chlorine. Are you listening, children? Got it? Okay, we will see the next one. Melting and boiling point of solids and liquids. Melting and boiling point of solids and liquids. Now, temperature, melting and boiling point of solid and liquid. We are studying about melting and boiling point of solids and liquids. Now, temperature at which a solid changes to liquid. A solid changes to liquid at atmospheric pressure. இந்த வெப்பநிலையில இந்த வளிமண்டல அழுத்தத்துல how the one state to another one state. We listen. The temperature at which solid changes to liquid at atmospheric pressure, that is called melting point. So melting point of ice, that is equal to 0 degrees Celsius. Melting point of ice is equal to 0 degrees Celsius. Now, boiling point of water. Boiling point of water. How water should be boiled? What is the boiling point of water? What is the boiling point of water? What is the melting point of ice? What is the melting point of ice? The melting point of ice is 0 degrees Celsius. The melting point of ice is 0 degrees Celsius. What is called melting point or fusion point? The temperature at which a solid changes to liquid. Temperature at which a solid changes to liquid at atmospheric pressure. That is melting point. Another one name is fusion point. Now, boiling point. What is called boiling point? What is called boiling point? Temperature at which liquid boils and turns to vapor. When the liquid boils, it turns to vapor. It turns to vapor. So that is called boiling point. That is called boiling point or vaporization point or vaporization point. So what is the boiling point of water? 100 degrees Celsius. How much degrees Celsius? 100 degrees Celsius. Okay children, still now you studied about physical properties of substances. Physical properties of substances. We have seen a lot. You look at them, you study them, you read them and study them. Now chemical properties of substances. Now we will study about chemical properties of substances. Here chemical properties of substances are their reactions with acids, bases and other reagents. Acids, bases and other reagents. Now substances. Substances is a matter. Substances is a matter that which has a matter has a specific composition, குறிப்பிட்ட கலவை and specific property, குறிப்பிட்ட பண்புகளை உள்ளடக்கியது, குறிப்பிட்ட பண்புகளை கொண்டது, குறிப்பிட்ட கலவை மற்றும் குறிப்பிட்ட பண்புகளை உடையது. So they have a specific composition and a specific properties. Now substances may be pure or impure. May be pure or impure. Now will you listen here? You look at the chart children. It is in page number 25. Substances, pure substances, impure substances. What are pure substances, impure substances? Pure substances, elements, compounds. That definite characteristic property. They have definite characteristic properties. So that they are an example of pure substances. Now impure substances, what about impure substances? Mixture. They don't have definite characteristic properties. They do not have definite characteristic properties. This is a difference between pure substances and impure substances. This is a difference between the pure substances and impure substances. Now we will study about differences between elements, compounds and mixture. What is that? Differences between elements, compounds, mixture. Now children, it is not in the slide. You look at, you take a book, page number 26. Elements, compounds, mixture. What are the difference? What are the differences here? You see only two differences, 2 or 3 differences given here. 2 or 3 differences. Listen, first of all, we study elements. We study about elements. Pure substance. That is only one type of atom. A pure substance made up of only one type of atom. That is one kind of atom. Next, compounds. Pure substance made up of 2 or more kinds of compounds. So it should not be one. It should be more than 2. It should be more than 2. So that pure substance made up of 2 or more kinds of atoms or elements. More kinds of atoms or elements. Next, mixture. Impure substance made up of 2 or more kinds of elements or compounds or both. That's why mixture. So through this name mixture, we can understand it should be impure. It should be impure because it has elements and also compounds. It has the properties of elements and also compounds. Now, second point, these elements cannot be broken down into simpler substances because there is only one type of atom. So we cannot be broken down into simpler substances. We cannot be broken down into simpler substances. Then now compounds. chemically combined in a fixed proportion. Compounds chemically combined in a fixed proportion. The mixture mechanically mixed in any proportion. It is not joined chemically. It is not joined chemically. Now, next point in compounds, only be separated by chemical method. The compound should be separated by chemical method. Mixture can be separated by physical method. Mixtures can be separated by physical method. For you see here, for example, gold, water, H plus O plus H. So 2 hydrogen, 1 oxygen. That's why H2O. Loses the original properties of atom. It loses the compounds loses the original properties of atom when combined. You see, loses the original properties of atom. When combined, they loses original properties of atom. The next for here mixtures air. Air, because we know air is a mixture of gases. Air is a mixture of gases, oxygen, carbon dioxide, nitrogen, inactive gases. So, the mixture example is air. That retains the properties of different elements or compound. This one retains the properties of different elements or compounds. Now, next we will study about types of mixture. Types of mixture. 2 types of mixture. Homogeneous mixture and heterogeneous mixture. Homogeneous, what about homogeneous mixture? What about heterogeneous mixture? Composition of the mixture is uniform. Homo, that is same. Homo means same. So that's why the composition of mixture is same. Throughout the matter, the composition of mixture is same. Otherwise, the composition of mixture is uniform. And moreover, the composition of mixture is same throughout the matter. Same throughout the matter. Now, heterogeneous mixture. Heterogeneous mixture. Composition of the mixture has no uniformity and they vary throughout the mixture. Here there is no, it is not same. The heterogeneous mixture, the composition of mixture is not same. That is different. Now, next, components of the mixture are uniformly mixed. Heterogeneous mixture, the components of the mixture are not mixed uniformly. The next, here homogeneous mixture example, salt and water. Sugar and water we can take. Here heterogeneous mixture, sand and water, or water and oil, iron and sand we can take. And these are few more examples. Of heterogeneous mixture. Next, separation of mixture. Next we will study about separation of mixture. Now look at this, children. Look at the slide. Separation of mixture. Different separation techniques may be employed for the separation of homogeneous and heterogeneous mixture. Different separation techniques may be employed, may be used for the separation of homogeneous and heterogeneous mixture. First of all, solid liquid mixture. For solid and liquid mixture, what are the different separation techniques employed? What are the different separation techniques? Filtration, sedimentation, evaporation, distillation. What all? Filtration, sedimentation, evaporation, distillation. Now listen more. I will say something. Here, electric wire Before that I will say something. Electric wire is made up of metals. Electric wire is made up of metals. Because the metals, what are the properties? What they have? A good conductor of electricity. Because metals are good conductor of electricity. Silver, for best some example, silver, copper, they are the best conductor of heat also. They are the best conductor of heat. Electric wire is made up of insulator. Electric wire is made up of insulator. Now next, we can see the particles of heterogeneous mixture. Already we know. Yes, homogeneous. We cannot see the particles of homogeneous, but we can see the particles of heterogeneous mixture through our naked eye also. Through our naked eye. But homogeneous, it cannot be seen, and also it cannot be seen under the microscope also. Under the microscope also. Now, separation of mixture, different separation techniques for solid liquid mixture, for solid and liquid mixture, filtration, sedimentation, evaporation, distillation. What are filtration, sedimentation, evaporation, distillation? First of all, we study about filtration to separate the mixture of insoluble solid X and from liquid component Y. Insoluble, it is you look at the book, children, take your book, see, look at page number 26. Insoluble solid filtered using filter paper. We are using filter. When we use filter paper, insoluble solid filtered. The filter paper is made into a cone and is placed on the funnel. It is shown in figure 3.1. It is shown in figure 3.1. Now it is on the slide. Listen, children, look at the picture. What do you see? This is separation by filtration. Separation by filtration. Now you are looking the picture, that is separation by filtration. Now listen here, this separation by filtration, it is using, this is the filtration method. This is the filtration method. Insoluble solid filtered. How the insoluble solid filtered? Using a filter paper. So, separation of components on filtration. Separation of components on filtration. Insoluble solid X remains on the filter paper. It remains on the filter paper, which is dried and recovered. Which is dried and recovered. Liquid component Y remains in the lower beaker. Remains in the lower beaker. So, everyday application in water filtration plants. நீரை வடிகட்டுதல். In water filtration plants. This filtration method in everyday application, for example, water filtration plants, we are using this. Next, in a coffee maker. After that, using a strainer during a tea preparation. During strainer, vadigatti. We are using strainer. During the tea preparation, first you are using the strainer. After that, we drink tea. Evaporation. Next we study about evaporation. Now, children, look at separation by evaporation. Separating mixture by the process of evaporation. Here you see Bunsen. Look at the picture. Bunsen burner, heat, evaporation basin, solution, after solvent vapor. Here, to separate the mixture of soluble solid, sodium chloride from liquid component Y. example water. From water we have and sodium chloride, we have to separate these two mixture. Place the mixture of X and Y in an evaporation basin. Here there is evaporation basin is given. So the mixture of X and Y in an evaporation basin. We have to heat it. Carefully as shown in this figure. The flame is adjusted to prevent the solid from coming out. The flame should be adjusted to prevent the solid from coming out. So here you see solvent vapor. How the solvent vapors are there. Bunsen burner, how heat comes out. So these are separation by evaporation. Separation of components through evaporation. Separation of components through evaporation. Solid components X remains in the evaporation basin. When we heat that, which one comes out? Water becomes water vapor. Yes. So solid component X remains in the evaporation basin, which is recovered on the evaporation. Whereas the liquid component Y is lost in the form of water vapor. Everyday application. For drying wet cloth. For drying wet cloths during the summer season, the dried what is that? The wet cloth takes dries soon. Wet cloth dries soon. But rainy season, wet cloth becomes dry. It takes time. So here for this evaporation method used for drying wet cloth. Then salt is obtained from sea water. From கடல் நீரிலிருந்து உப்பு எடுக்கிற முறையிலையும் இதை என்ன செய்றாங்க? Separation method is using from sea water. Because for getting the salt, we are obtaining salt from sea water. That means we are obtaining the salt from sea water. Next, salt is obtained from solution in a laboratory. Salt is obtained from the solution in a laboratory. So for the everyday application, these are everyday application, how the separation of components through evaporation. Next, sedimentation and decantation. What is that? Sedimentation and decantation. Sedimentation vandal, that is in Tamil word vandal. Decantation தெளிய வைத்து அவைகளை இருத்தல். Now sedimentation and decantation using sedimentation and decantation. Now listen children, look at your book, page number 27. Sedimentation and decantation. Using sedimentation and decantation we have to separate the mixture of insoluble solid X from liquid component Y. Insoluble solid, example sand. Solid component, example water. So insoluble solid settle down at the bottom. Already we know. When we take water and sand, the sand settle down at the bottom and the liquid is decanted out. Carefully using a glass rod. Now after you look at this picture, page number 28. Water containing insoluble first one beaker, water containing insoluble particles. So which process is going on? Sedimentation process. Now you see sand settled down at the bottom. Clean water is there. Is on. Then using the glass rod, decanted clean water. We have to decant clean water. This method is sedimentation and decantation. This process is sedimentation and decantation. Separation of components. What is that? Separation of components by distillation. By distillation. After that we will study about separation of components by distillation process. Here this sedimentation and decantation everyday application, addition of alum to drinking water. Addition of alum to drinking water. Separation of heavy solids in the laboratory. Obtaining clean water from muddy water. For this all purpose we are using this process. These all purpose we are using these all the purposes we are using by sedimentation and decantation. Now distillation. What is that? Distillation. The next one is distillation. Using distillation process we have to separate the mixture of soluble solid from liquid component. Soluble solid, that is sodium chloride. You see the distillation, separation by distillation process. Now children, separation by distillation process. You see here, using the distillation process to separate the mixture of soluble solid sodium chloride, then from liquid component water. Solid component remains behind and liquid component evaporates and is recollected by condensation. The mixture of X and Y is added to a flat bottomed flask. Mixture of X and Y, that you see that a flat bottomed flask. What we added? The mixture of solids and water. The mixture of solids and liquids. So the mixture of X and Y is added to a flat bottomed flask of the distillation apparatus. This is distillation apparatus. So it is the mixture is added to a flat bottomed flask. The flask is heated. Now the flask is heated, whereby the liquid evaporates and is recollected in the receiver flask, that contain a Liebig condenser. This is a separation of components by distillation. Next, fractional distillation. You see children, already I have shown that separation by distillation picture. Yes, so the heading separation by distillation. Okay, how the components are separated by distillation. Listen children, before we see the chromatography, we will study about the fractional distillation. It is in book page number 28. Now, using fractional distillation process, the mixture of two miscible liquids can be separated. That mixture is alcohol and water. When the alcohol-water mixture is heated in a distillation flask, they fitted with the fractionating column. When the temperature at the top of the fractionating column reaches the boiling point of alcohol, that is 78 degrees Celsius, then the alcohol vapors pass through the condenser and gets cooled and collected in a beaker. This is a fractional distillation. So here, advantages of distillation over evaporation, both the components can be recovered. What is the advantages of distillation and evaporation? Both the components can be recovered. Then separation of components. Soluble solid component X remains behind in the flask. Behind in the flask. Liquid components get collected in the receiver flask. Receiver flask. So everyday application, refining of petroleum fraction, obtaining distilled water, separation by distillation, these are the separation by distillation. So refining of petroleum fraction, obtaining distilled water, then separating funnel. Separation of components through separating funnel. Separation of two immiscible liquids. Water occupies the top surface in the beaker, where oil will settle down at the bottom. Water occupies the top surface in the beaker. So how to separate the mixture of water and oil? First we have to use a separating funnel to separate two immiscible liquids. Let the mixture stand still for a few minutes. After some time, you will observe that two layers of oil and water will be formed separately. Separate using stopcock and let the lower layer of the water pour out in a different beaker. Close the stopcock as soon as you see the oil reaching the stopcock. So how do we separate a mixture of water and oil? These all we have to use. This all. Everyday application, separation of iron from its ore. Separating any two immiscible liquids. Example oil and water. Now, listen children. We will study about the chromatography. Who is a great person? He is a Mikkel. So now listen, before that you study chromatography. What is that? Chromatography. It is a separation technique employed for complex mixture. This is a separation technique. This is another one technique. Listen, for separating the mixture of different solid constituents in a liquid component. To separate the mixture of different solid constituents in a liquid component. Principle: difference in absorption of the solid constituents. Example: dyes in the ink. Dyes in the ink on the surface of an adsorbent medium, that is filter paper. This technique uses two types of substance. One is mobile phase, another one is stationary phase. Another one is stationary phase. So here a gas or liquid transport the solution being tested through the other substance. A gas or liquid transports the solution being tested. While being tested, they transports the solution through the other substance. Then stationary phase, the liquid or solid through the tested substance is carried through the tested substance, through which the tested substance is carried. Example: coffee filter paper, paper towel. Okay. So they differentiate into mobile phase and also stationary phase. So you have to study this example and what is the difference. You must study them. Then discovery of chromatography. Now this great person Michael invented the chromatography in 19 during his research on plant pigments என்று சொன்னால் நிறமிகள். So during his research on his research on plant pigment, he invented the chromatography. He used liquid adsorption column chromatography with calcium carbonate as adsorbent and ether ethanol mixtures as eluent to separate the chlorophyll and carotenoid. They separate chlorophyll and carotenoids. They separate the chlorophyll and also carotenoids. Now look at this activity 1. Activity 1. A. To study whether the dye in black ink a single color or not. It helps to study whether the dye in black ink is a single color or not. Now materials required: a thin strip of chromatography paper, pencil, glass beaker, ink. Take a thin strip of chromatography paper, draw a line on it using a pencil approximately 3 cm above the lower edge. Then put a small drop of ink at the center of the line. Let it dry. Lower the chromatography paper into a glass or beaker or test tube containing water so that the drop of ink on the paper is just above the water level. It is shown in figure 3.6 and leave it undisturbed. Observation: what we are observing here? What we are going to observe here? First, a water rises on the chromatography paper. It takes with it the dye particles which is soluble in water. Since a dye is a mixture of two or more colors, the colored component that is more soluble in water rises faster, and in this way the colors get separated. The same technique is used to separate pigments from natural color. Then drugs from blood. So these are the observations. So through this chromatography we are observing this all. It helps to find the chlorophyll and also carotenoid. It helps to separate the chlorophyll and carotenoids. Here children, sublimation, padanga madal. Sublimation is the property of substances in which they are converted directly from solid to gas or vice versa. So these substances are known as sublimes. For example, ammonium chloride, camphor. Ammonium chloride and camphor. Listen, sublimation, the property of substances in which they are converted directly from solid to gas. So, camphor, that is chewed. We are using camphor. Yes. So when we are keeping out, the camphor is a solid. When we are keeping out, it becomes gas. It converts into gas. So sublimation is the property of substance in which they are converted directly from solid to gas. These substances are known as sublimes. For example, ammonium chloride, camphor. Take a white solid ammonium chloride in a china dish and place it over a burner and cover it with inverted funnel. Close the mouth of funnel with cotton. Now heat it. After some time you will see some vapors on funnel. This shows that ammonium chloride undergoes sublimation. Okay children, still now we are studying about elements, compounds and mixture, properties of substances, physical properties, chemical properties. Then after separation of mixture, what are the separation of mixture, what are the process, separation of mixture, in that many methods we use to separate the mixture. Filtration, how we are separating the mixture, filtration, sedimentation, evaporation, distillation and also distillation, and these all methods we used. After that the chromatography method also we have seen. So this lesson we finished today. We will study study all the questions, okay, what are given in the book bag, you study. After that, today I am giving only one. I typed 5 questions, but here only one question is printed. Through the next slide I will show that question. Now children, take your classwork. Only one question printed. I forgot to make it again, so sorry for that. So you write this question. Through the next slide I will come with this third lesson's classwork, okay children, and we will see the next lesson also. Classwork question: substance dash may be pure or impure. Dash may be pure or impure. Substance. Underline the substance. Okay children. So today we will close the class today. We will meet again. Meet in the next video. Okay children. Thank you.